When I'm dividing a polynomial by a polynomial, when my denominator has more than one term, one way to take care of this is by doing long division with our polynomials. Now, it's very helpful to remember what we did in long division of numbers to be able to then shadow those steps when we're finding the long division answer to a polynomial divided by a polynomial. So let's first come over and recall what we did when we're looking at division of whole numbers. So let's say, for example, we were dividing 12 into 378. Well, if we're dividing 12 into 378, the first thing we would do is say, what times 12 gets me closest to 3 without going over? And since you can't do that, then you would go and move down another place value. What times 12 gets us closest to 37 without going over? Well, 3 does that. And then we take the 3 times the 12. Well, 3 times 12 is 36. And we write it underneath our dividend. And we subtract as part of the division process. So 7 subtract 6 is 1. And 3 subtract 3 is 0. So I have just my 1 there from that first stage of the long division. Now remember, we again would then take and bring down the next number in our division process from our dividend. So when we bring down the 8, we would start again. What times 12 gets me the closest to 18 without going over? Well, 1. So we would put that up in our quotient. And then we take just this 1 that we are at the current stage of, times the divisor 12, write it underneath in our process, and subtract. So 8 subtract 2 is 6, and 1 subtract 1 is 0. And then when we ended up with our remainder that was smaller than the divisor, if we weren't going into decimals, then we would stop our division process there. And remember, we would report our answer as our quotient, 31, plus our remainder, 6, over our divisor, 12. With numbers, we had a little bit more of a shorthand way of writing this. We would simplify our fractional value that we created from our remainder over our divisor, if we can. And here's 6 in the numerator, 12 in the denominator. We can remove a common factor pair of 6 in the top and the bottom and give us 1/2 there. And 31 plus a half, we just would write as 31 and 1/2 in mixed number notation. But we could do that with numbers. Now, when we look at how we can carry that out with our division and our polynomials, I have my numerator is the dividend, so I'll write my 5x squared minus 3x plus 10, and my denominator is my divisor, so I'm dividing that by x minus 3. Now, it's helpful to make sure that you have your polynomial in descending order, meaning you've got your highest degree term first, and then the next degree down term after that on down the line. So I have a squared term, a first degree term, and a constant term. And then in my divisor, I have my first degree term and my constant term. If my polynomial had the terms mixed up in their powers, then I would rearrange the terms so it's in descending order. And if there was a power that was missing, I'd make sure to leave a space in that part of the dividend, so I have a way to line things up when I'm going through the division process. Okay, so what we want to do is start similar to what we did over there. Remember, we said what times 12 gets us close to 3 without going over, and if there wasn't anything for that, we would move over to the next place value to say what times 12 gets us closest to the 37 without going over, and figured it from there. Well, in polynomials, what you do is you look at just the first term of what you're dividing into, this 5x squared, divided by the first term of what you're dividing by, the x. And then just simplify this like you simplify from just your rules of exponents. So 5x squared over x, when I simplify it, is just 5x. So that's what I put as the first term of my quotient. Now, once we put the first term in our quotient and we're ready to carry out the next stage of the division process, we take that first term of our quotient and multiply it through our entire divisor. So when I take this 5x and multiply it through the x minus 3, I get 5x squared minus 15x. So I'm going to write that underneath my dividend, my 5x squared minus 15x. And now remember, in the division process, the next thing we're supposed to do is subtract. And with numbers, we subtracted our place values, and it was all kind of nicely tight there with our viewing in the place values. With polynomials, it's kind of spread out. So when we do that next process of subtracting, the easiest way, or a way that you might want to consider, I know I'm supposed to subtract this whole quantity that has more than one term. Well, when we subtract with more than one term, I can distribute that minus sign to each of the terms and then combine like terms column by column. So that's what we're going to do. So when I take this negative times the 5x squared, I'll get a minus 5x squared. And when I take the negative times the negative 15x, that'll take it to plus 15x. So when I'm at that stage of subtracting, I can actually change the signs of each term so that they're visually very closely to where we have to do the work. And I like to do it with a different color, even if I'm working on paper with it, just to make sure that I keep straight where I am in the process. Okay, so now 5x squared minus 5x squared, they cancel. Negative 3x plus 15x is 12x. And then we want to bring down the next term, plus 10. Now we start the process all over again. Take the first term of what you're dividing into, the 12x, and divide it by the first term of what you're dividing by, the x. Well, when I simplify 12x over x, the common factors of x will remove and I'll just get 12. So I want to put that 12 up in my quotient. And since I'm showing this is the next stage of the process, without a sign here, it's a plus 12. So I actually write plus 12 up in my quotient. And now I'm going to take that 12 and I'm going to multiply it through my divisor, x minus 3, to see what I'm going to need in the next stage of the process. So 12 times x is 12x. And 12 times negative 3 is a minus 36. So I write 12x minus 36, and I'm at the stage now where I want to subtract. So take out your other colored pencil and change the signs of each term and then combine to do that subtraction process. So that'll make that a minus 12x and a plus 36. 12x, subtract 12x, those terms are gone, and then 10 combined with a plus 36 is a 46. Now, as soon as the degree of what I have in my process is smaller than the degree of the dividend, of the divisor, I know that my division is done, and that's my remainder. 46 is my remainder, and my quotient is 5x plus 12. So if I want to write it similar to how I wrote my answers in my long division with numbers, I write my quotient, 5x plus 12, plus my remainder, 46, over my divisor, x minus 3. Now, I can't write it any more compactly than that, like I was able to do with the numbers, because in algebra, if we don't write the sign down between them, then it's assumed to be multiplication. And it's really an addition or subtraction, different terms that you get from this process. So the long division answer to the original question here I get an answer of 5x plus 12 plus 46 over x minus 30.